Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to go to the next one, which is finding the equation of a tangent and normal, okay, using parametric differentiation. So it's important that before you come to this video, make sure you've reviewed the 7 rules from the previous video, where I talked about, where I laid down the steps, so the 7 steps on how to do parametric differentiation to find the equation of a tangent and normal. You have to focus on step 5. So it's basically step 5 we're going to talk about here. So we're going to do maybe from step 1 to 3 to find the dy over dx. Then we'll now jump to step 5, where we're going to talk about how to find the equation of a tangent and normal. Is that okay? All right. And also, before I proceed, don't forget to like, share, and subscribe. And if you've not clicked notification bell, I don't know what you're waiting for. Please do so that when I post new videos, you'll be the first person to know. All right, let's get straight into it. Let's solve some example. So let's assume we have this now, this example here. So we're told that given we have y is equal to 2 divided by t, and x is equal to 2t squared minus 5, okay? We're now told to find the tangent and normal to the curve at the point 1 and 2, okay? So, and I want you to find it in ax plus by plus c form. No, I think let us leave it in yeah, ax plus by plus c. So remember, I told you in the equation of lines where you can have a standard form, the 1-point slope form, 2-point slope form. So in this case, they want you to leave it in the standard form. All right, so let's leave it in the standard form then. All right, so let's get cracking into this. So we have this. So the first step, we have to do step 1. Okay, so step 1, like I said, I said that you have to differentiate y in respect to x or in respect to t so that you can give you dy over dt. So we have y is equal to 2 over t, and we have to convert this to index form before you even begin to differentiate. So it will be 2t minus 1, right? So now to differentiate it, so dy over dt is going to be, when you differentiate this, so remember I told you when you have ax raised to the power n, it's going to be an x n minus 1, okay? So you multiply and you subtract 1. So have a complete series on differentiation. So please, you have to go back and have a look. So that's going to give us minus 2t minus 1 will give us minus 2, okay? Now the next one is for step 2. I told you then you have to differentiate x in respect to t to give you dx over dt. So we're going to have x is equal to 2t minus 5. Okay? You have 2t minus 5. Then the next thing we now have to find is dx over dt. Is it 2t or 2t squared? Let me have a look at this. Yeah, 2t squared. Let me bring this down. So I just saw 2t, okay? 2t squared. So there's a squared here. So dx over dt will be equal to 2t squared. 2 times 2 is going to give us 4t, and this is minus 5 is going to become 0 because when you differentiate a constant, it's going to give you 0. So step 3, okay? So step 3, I told you that you have to then divide dy over dt by dx over dt to give you dy over dx. So step 3, so I told you dy over dx is equal to dy over dt all divided by dx over dt. All right. So now this is going to give us the y over dt. We have minus, we have the y over dt. We have minus 2t minus 2, all divided by 4t. Okay. So we can now play around with this to simplify. So it's going to give us minus 2 t is going to be the same thing as saying divided by t squared, all right, divided by 4t, okay? So this is going to give us minus 2 over t squared times 1 over what? 4t, okay? So this is going to happen. 2 can go here, 1. 2 will go there, 2, okay? And that will give us minus 1 over 2t squared, give it t cubed. All right. So now we can now say, based on this, right? The dy over dx, which is the same thing as what? mt, right? Is equal to minus 1 over what? 2t cubed. And that will be the answer for that. Okay. Now, but that's not what we're looking for. Then we now have to, because we're looking for the equation of the tangent and normal. So we have to now jump to step 5. So in step 5, okay, so we're having step 5 now. So step 5i, I told you to substitute the y value into the original equation to get t, okay? So the y value, so if you go to the question, okay, the y value has to be this because this is going to be x and the y. So that means the y is 2 into the original equation to get what? T, okay? So let's go. So the original equation, so the y value is 2 to the original equation. So it's going to be y equal to 2 over t. So we're going to go back now. So we have it. So we had the original equation was y is equal to 2 over t, but we're substituting the y value into this. So therefore, we can now say at y is equal to 2. So it's going to have 2 will be equal to 2 divided by what? T, all right? Now, we're looking for t. Then what I'm going to do, I'm going to multiply both sides by t to get rid of the fraction. So that will now give me 2 times t will give me 2t will be equal to this t will cancel out this t will give me equal to 2. Now to get t, I'm going to divide both sides by 2. Are you seeing it? So that means this will cancel that. So we're going to have t will be equal to what? 1. So are you seeing it? So that means you substitute the y value into the original question or the equation to get t. So we've gotten the t now. All right. Now, the next part now is that step 2 now says substitute the value of t into dy over dx from step 3 to get the gradient. So that means we have to then, step 2, so step 5(2), okay? So it's very important that you go to the video and see all the steps, okay? So there you say we have to substitute the value of t into the dy over dx to get the gradient, okay? So now let's go and find what was the dy over dx we had. We had the dy over dx to be minus 1 over 2t cubed. So we had dy over dx was equal to minus 1 over what? 2t cubed. So now we're substituting the value of t. So that means we're substituting now when t is equal to what? 1. So that's what we had here. So it's going to give us dy over dx will be equal to minus 1 over 2. The t is what? 1 all raised to the power 3. Are you seeing it? So when you press your calculator for this, when you press your calculator for that, it's going to give us minus 1 over 2. So that means we can now say the dy over dx, which we already know. So therefore, we can now say dy over dx, which we know to be equal to what? Mt is equal to minus 1 over 2. All right. Now, we then have to then find the equation of tangent and normal. So step 5.3 was for equation of tangent. So we'll do that first. So for step 5.3, so 5I, okay? So now it was saying that if we're looking for the equation of tangent, so for the equation of tangent, we said it is y minus y1 is equal to mt x minus x1, okay? So now we can see here that we have our mt to be minus 1 over 2. Now the x and y was given in the original question, okay? So the x and y was given to be 1 and 2, all right? So now we can go back and use it to solve. So we now know for the equation of a tangent, so mt is minus 1 over 2. The x is equal to 1, and the y is equal to what? 2 now. So we can now solve this. So it's going to give us y minus y1, we give you 2, will be equal to mt, which is going to be minus 1 over 2. And we now have x minus x1 is going to give us what? 1. Are you seeing it? So we're going to have this. So it's going to become y minus 2 is going to be equal to minus 1 over 2x. Minus times minus is going to give us plus 1 over 2. So basically what I'm doing here is the a, b plus c. Okay, so a times b is going to give us ab. A times c is going to give us what? AC. All right. Now, the question wanted us to leave it in the form of ax plus by plus c, where a, b, and c are integers, right? So they wanted us to leave it in the standard form, okay? Let me clean this out first. So the question wanted us to leave it in standard form, if I remember correctly. So if you look at it here, yep, they wanted us to leave it in standard form, ax plus by plus c. So I've talked about the different forms in equation of a line. So please make sure you go back and have a look. And I think we did that in coordinate geometry playlist, okay? So you just go there and you can play around with it. So that means in order for me to do this, what I can do is that I take everything to the other side, okay? So first thing first, I need to get rid of all the variables on the right-hand side. I move it to the left. So easy, I'll move this now to this side. It's going to be positive. So it's going to become, the minus become plus. So if you cross over the equal to sign, and also if you cross this over as well, it becomes minus. So if minus 1 over 2 crosses over, it becomes minus. But before I do that, I want to get rid of all these fractions. So I'm going to multiply through by 2. Okay, so that's the best way to get rid of the fractions. Okay, so that means this is going to give me now 2y minus 4 is equal to half. This is going to give me minus x plus 1. Are you seeing it? So now it looks easy for me to work with. Now, so we're going to take all this to the other side. So I'm going to take minus x to the other side, or you can add x to both sides and you subtract 1 from both sides. Apparently, students prefer the adding and subtracting, so I'm going to do that. So what I'm going to do now, to get rid of this x, I'm going to add x to both sides. Okay, I'm going to add x to both sides. So we're going to have x plus, okay, 2y minus 4 will be equal to, we're going to have x. Now we have minus x plus 1. So this will cancel out that. Then we'll now do the next one. So we need to get rid of this 1. So I'm going to subtract 1 from both sides. So we're going to have x plus 2y minus 4. Then minus 1 will be equal to 1 minus what? 1. So that is going to give us x. So 1 minus 1, this is going to cancel out to give you 0. With x plus 2y minus 4 minus 1 is going to give us minus 5 is equal to what? 0. And this is going to be the equation of a tangent in standard form. Okay? Now, but just for calculation's sake, if, for instance, you were told to leave it in standard form, so if, for instance, you were told that you should leave it in y is equal to mx plus c form, all right? So you can also do that. So you can have x plus 2y minus 5 is equal to 0. I take everything to the other side. So it's going to be 2y will be equal to minus x plus 5, okay? Then I divide both sides by 2 to get rid of make y to be on its own. Then that will now give me y will be equal to minus 1 over 2x plus 5 over 2. All right? So usually if you're asked to leave it in the y equals to mx plus c, that's how you will leave it, okay? But the question wanted us to leave it in the standard form. All right, so that was how to find the equation of a tangent. But the question also wanted us to find equation of a normal, all right? So we're going to do that as well to find the equation of a normal, and we're going to proceed. So let's assume we have in this. So that's the equation of a normal. Let me use something. Let's see. Right, let me use a black pen then. So I want to write it parallel to each other. So now so we've done that. So we want to do now equation of a normal. Okay. So equation of a normal, we know that to be y minus y1. So instead of us having mt, we're going to have mn, x minus x1. Are you seeing it? Now, but first we need to find mn, because we know that mn is equal to minus 1 over what? Mt. So that's the only step. And from this question, we knew our mt already in step 4 to be minus half, okay? So now we can now say it's going to be minus 1 divided by minus half. And when you press the calculator for that, that will give you 2. So now we can say our mt is equal to 2, our x is equal to 1, and our y still remains as what? 2. Does that make sense? Now we can now solve this now. So we're going to have y minus our y1 is going to give us 2 will be equal to, so you can draw a straight line here so that you can know it's different. Okay, let me do that so that some students will not get confused while solving. Okay, so we have that. Okay, yeah, that looks good now. So we now have y minus y1 is equal to mn. Mn is 2. Then we now have x minus our x1 here is also 1. And then that is that for that. Okay. So we have that. We now open the brackets. It's going to give us y minus 2. It's going to be same thing. What we talked about, a, b plus c. It's going to be this times this will give you ab plus this times this is going to give us ac, right? So we're going to apply the same principle here. So 2 times x 2 times x is going to give us 2x. And 2 times minus 1 is going to give us minus 2. Okay. Now, because we are leaving it in the form of ax plus by plus c, so we have to take it to the other side. So you can either want to subtract 2 from both sides and add to those sides if you want to, or you can just move it over the equal to sign, all right? Like I said, students prefer the subtracting and adding to both sides. So I'm going to do that. So I can decide to subtract y from both sides. So I want to take everything to the other side. So it's going to be minus y, okay, plus y minus 2 is going to give us 2x minus y minus 2. Okay, so this will cancel out that. Then I want to take this 2 away, minus 2 away from here. So I'm going to add 2 to both sides. Okay, so it's going to give me, take this up a bit. So it's going to give me, we are going to have minus 2, okay, plus 2 is going to give us 2x minus y minus 2. Then we're going to have plus 2, okay? So the same thing, minus 2 will cancel plus 2, and minus 2 will cancel plus 2. So then we're going to have, this will be 0 will be equal to 2x minus y. So therefore, we can now say 2x minus y is going to give you what? Equal to 0. And that will be the answer for the equation of a tangent. Now, if, for instance, the question wanted it to be in the form of y equals to mx plus c, okay? Similarly, if it wanted it to be in the form of y equals mx plus c, so if it wanted it to be y equal to mx plus c, okay, the same thing, you're going to have 2x minus y is equal to 0. I'll take y to the other side. Okay, so it's going to be 2x is going to be equal to y. All right, so or we can say y is equal to 2x, so the mx, then the c is 0, and that will be the answer for that. All right, that is it for that, and we're done with that question. So we're going to move to the next part. We're going to talk about how to find the angle from the horizontal using parametric differentiation. So it's important that you subscribe and click the notification bell so that when I post the next video, you'll be the first person to know. And also you will notice as well that this is the same principle. So you have to just go to the textbook and practice. And you have to practice with more questions. You have to practice from the worksheet as well. And if you have any question that you don't understand, please don't hesitate to contact me and I will get back to you as soon as I can. All right, so I'll see you in the next video and I'll see you soon. All right, thank you very much.